All right, guys, welcome to the final asynchronous day for the semester. What we're going to be doing today is just another review of some of the concepts that we had previously learned, and then you guys are going to be, so that you feel comfortable with it as we practice it in our current unit. But one of the things that we wanted to do was also include part of our, what our first asynchronous day was, and that was to do a grade review. So in Infinite Campus, let me start over again. You should log on to IRC, and in IRC, it reports your grade as like a 1 grade / and then a 2nd grade. So we want you to record both grades in there, but we want you to understand something. So the grade in the first line here, that is the grade that if we were end today, based on the algorithm and the evidence, that's what your grade would be. The second grade on the second line here is kind of saying, where are you trending towards? Make sure that you have conversations with us and look at your evidence. That doesn't necessarily mean that you're guaranteed to end up with that grade. It means that there might be a possibility of that grade. So you might see a C/B, and students might say, well, I can get a B, or I'm going to get a B. Again, you got to be really careful of that and looking at the evidence to make sure that that's accurate. So make sure to, stay after class and ask us a question and follow up with that if you're not sure. Okay. So then the last 3 days of school, the 14th, 15th, and 16th of December, we're going to have what they're calling culminating experience days, traditionally final exams. So you're going to have the opportunity to show additional evidence of your growth. Based on your grades, what I want you to do is circle or highlight the standard that you think you're going to need the most assistance in to show growth. So that's either standard 1, creating mathematical representations. So part of standard 1 is doing things like marking your diagram, notations, writing equations. Those are things that are going to fall under standard 1. And then standard 3 is analyzing and interpreting. So making sure that once you find an x value, you know how to substitute it in, using foldables to justify setup equations. We do also have a standard 2. It's embedded within your other 2 standards and does not be reviewed, or it's not going to be assessed separately. So it's just a part of the other ones. So what I want you guys to do is go ahead and hit pause, go into IRC, record those grades, look at your standards, circle the standard that you think you're going to need the most assistance with, so that we can kind of have that in mind as we're thinking about how we're going to use our review days before we head into those culminating experience days. All right, so now that we are unpaused and you guys have done part 1, we're going to jump into part 2. And this is talking about perpendicular lines or segments. So when we're talking about perpendicular lines or segments, we're talking about, 2 objects or 2 things that create a 90-degree angle. So we can describe the objects, the lines or the segments, as being perpendicular, and because they are perpendicular, they create that 90-degree angle. So that answers our first 2 questions essentially. So what is the symbol used to show segments or lines are perpendicular to each other? It's this upside down T. So that upside down T there is going to tell you that things are perpendicular to each other. So you might see me write something like segment BA is perpendicular to segment D. Sorry, guys. To segment DC. Okay? And that upside down, I read it as perpendicular. Then we just said those perpendicular lines or segments form right angles, and right angles, remember, are 90 degrees, so that's really important. Okay, so what I'm going to ask you guys to do now is to pause the video, and I want you to try examples 2 and 3. I'm sorry, 3A and 3B. After you have your answers, I want you to unpause and watch my work and make any corrections. Okay, so now that we've tried examples 3 and 3B, let's see how I would recommend that you approach this. So we were starting by told we have segment EB. So segment EB is right here. Here's point E to point B. And we want to know what segment it's perpendicular to. That's what this upside down T stands for. What segment is it perpendicular to? So EB, I see this box here. That box goes there. And then it touches, that box touches this other segment here. So that box touching this other segment tells me that these two segments together made that 90-degree angle. So segment EB is perpendicular to segment DB. And that's how I can identify it. By where that 90-degree angle, which two segments it's touching, those are my perpendicular segments. The other thing that I can look at is this idea of measure of angle 2. So the measure of this angle plus the measure of this angle. So these two angles together, what would they add up to? Now there's no quantities in there, so you guys might have been thinking, well, how would I figure that out? You want to remember that these two angles make up this larger angle that's 90 degrees. So I know no matter what, those two angles have to add up and equal to 90. So this goes back to like supplementary and complementary angles that we talked about in Unit 2, where we're using the idea of part plus part equals whole, where the two parts are your measure of angle 2 and measure of angle 3. But we know that the two parts are going to equal up to the whole, which is 90 degrees. So let's go ahead and try it in another example. So I'm told that given ray YX is perpendicular to ray YZ. All right, so I'm just going to start with that information here. So I have ray YX, so here's Y to X, and it's a ray, so it goes on forever in one direction. It's perpendicular to YZ, so here's YZ, it goes on forever in one direction. And I am told they are perpendicular. If I am told that they are perpendicular to each other, I know that these two rays will create a 90-degree angle. So I'm going to put that box in there because it tells me that together those are equal to 90. I am then given the measure of angle AYZ. So I start at A, I go to Y, and then I end at from Y to Z. So I made a little error, so I corrected it. So this angle here is the measure of 2x plus 8. And I know the measure of x, y, a. I start at x, I go to y, I go from y to a. So it's the measure of that angle there is 3x plus 7. Okay, so I'm given these two smaller angles. I need you guys to pause the video and set up and solve an equation to determine the value of x. Okay, so welcome back. All right, so you guys should have your work down there. I want you to compare your work to my work, so I'm going to put my work over on the side here. So what I notice is I have two smaller angles that are making a larger angle. So they're coming together to make that larger angle. And the measure of that larger angle is 90 degrees. And I know that because of that box there. So what I can use is my part plus part equals whole relationship. So the two smaller angles, my two parts, are 3x plus 7 plus 2x plus 8. Those are the two smaller angles that make up the whole angle, which is 90 degrees. To solve this, I'm going to combine my like terms. So I have 2x's, which is 5x, and I have 7 and 8 plus 15 equals 90 degrees. I'm going to use my inverse operations by subtracting by 15 on both sides. And I'm going to divide by 5 to isolate my x value. So I want you to look at your my work section. Match your work to my work. Did you set up part plus part equals whole? That's standard 1B. That's standard 1B. Can I set up that appropriate equation? Could I combine my like terms and use my inverse operations properly? That's standard 2. How did you do on that part? And then standard 1A, just to reinforce, was like marking that 90 degree in your angle there. Putting that box in right here. This was your standard 1A. Making an appropriate notation. So just going back to that as we reflected on the standards that we need the most work on. So make some corrections, pause if you have to, and then we're going to move on to the next one. So the next idea that we want to remind you about is bisectors. So we reminded bisectors with segments and a segment bisector, and we did some of that with the parallelograms. All right. But you can also have an angle bisector. And an angle bisector is just like a segment bisector in the fact that it splits something into two equal parts, except when you have an angle bisector, it's splitting an angle into two equal parts. So it wants you to fill in the blank. What is the bisector of angle PAD? So to find this angle, here's point P. So P to A to D, here's my angle. What has bisected? What has cut that angle into two equal parts? So I'm going to give you guys can pause. I'm going to give you a minute to answer that question. Okay, so this ray right here, AE, right, AE is what has bisected that angle. Now, how do I know it's ray AE? I'm using the loops, guys. So this loop here and this loop here tell me that these two angles are congruent to each other. If these two angles are congruent to each other, that means that it's been split into two equal parts. So ray AE had to split my big orange angle, my angle PAD, into two equal parts. Ooh. Had to split my larger angle PAD into two smaller equal parts. All right, the next thing I'm given is if the measure of angle PAE equals 48 degrees, then determine the measure of angle DAP. So here's PAE, P to A to E, and that's 48 degrees. And what it wants me to find is the measure of angle DAP, D to A to P. Right? The question is to find the measure of this angle here. I want you guys to go ahead and pause the video and see if you can figure out the measure of angle DAP. Okay, after taking the time to do your calculations. All right, what we should have recognized here is a measure of angle DAP is made up of two smaller angles. It's made up of this angle here and this angle here. So these two smaller congruent angles make up the larger angle. So since they each have a loop in them and they're congruent, the measure of angle DAE is also 48 degrees. That is this idea of part equals part. The two parts are congruent, so they are equal to each other, so I can use the same quantity. Now, if I want to find the measure of angle DAP, I'm going to use what we used before, that idea then of part plus part equals whole. Where I don't know the whole this time, I only know my two smaller parts. So I'm going to add up my two smaller parts to equal the whole, and the whole would be 96. So it's what we've been playing with all the way since August, is that idea of bisectors, splitting things into equal pieces, or using part plus part equals whole, or part equals part, using these same ideas in new and different contexts. So remember, you guys can always pause whenever you need to, but we're going to go ahead and move on to example 6. Just feel free to hit pause if you need to write a couple more things down. All right, so our last example today is, look at this. We do have a quadrilateral in here. It's a four-sided figure. It's a quadrilateral. And I am told that segment BC, given segment BC, bisects angle ABD. Okay, let's find that angle. So angle ABD. Here's my big angle. And BC has bisected it. This segment has bisected angle ABD, so it's cut it in half. If it's cut it in half, it's cut it into two smaller equal parts. if the measure of angle ABC is 5x plus 12, so from A to B to C, this part here, okay, 5x plus 12, and the measure of angle ABD, so ABD, that's my big one, my pink angle, A to B to D. If this one is 7x plus 33, determine the value of x. So what I want you guys to do is right now go ahead and pause the video. I want you to set up the equation under the My Work, set up and solve. Leave space for me. I'm going to put it under the My Teacher's Work for you guys to see. Okay, so what we had said is when we get into bisectors, we have that choice of doing part equals part or part plus part equals whole. And in reality, you're going to have to use both relationships in order to really figure out everything of this in this problem. So 5x plus 12, this is a part. This is a smaller piece of the larger angle, which is 7x plus 33. So we can't just set those two equal because a part doesn't equal a whole. That's not a choice that we have. But we do know that these two smaller angles here and here are congruent to each other. That single blue loop tells us they're congruent. So they are the same. So 5x plus 12 and 5x plus 12, those are congruent. They're the same. So that's how I'm using that part plus part equal relationship, is to fill in and label my whole diagram, to be successful with my 1A and showing my notation and filling that in, okay? But now what I need to do is if I want to set up and solve my equation, I need to use part plus part equals whole. That's the only thing that's going to get me to my x. So my two smaller parts are the two smaller angles. And that's going to equal my whole, which is the measure of the larger angle. I have to start this time by combining my like terms when I'm solving. So for your standard 2, what we're assessing is you being able to combine like terms. And then to be able to use inverse operations to isolate your x value. And to solve for x. And I'm going to just check, was that all that it wanted me to do? Yep. So that's all that we had to do. So we have standard 1A, which is labeling the loops in here, showing that it's bisected. We have standard 1B, which is right here, setting up your equation. And then, like we said, standard 2 is embedded by seeing the solving work done. Okay. So again, this is intended to be a review. We did show how it could potentially look in a quadrilateral. We put it in there. But it is a review of information that you have done that we're now going to use in our quadrilateral. So hopefully this will help you as we get into the next part of our unit. I will see you guys tomorrow.